In Lesson 2.7, the target states, I can compare and order fractions and decimals. For this lesson, we're going to review several things you're going to need to remember to compare fractions, mixed numbers, positive and negative fractions and mixed numbers, and to compare decimals. Let's take a look at a common way to start thinking about this problem, and that's comparing two numbers with the same denominator. For instance, we're going to compare 4/9 and 7/9. To compare 4/9 and 7/9, you'll notice that they're both ninths. They both have the same denominator. So if we look at what 4/9 looks like, if I had a tile broken into 9 sections, 4/9 would be 4 of them. And if I had the same tile, but this time I was looking at 7 of the 9 sections in the tile, or the strip, what I can see is that 7/9 is greater than 4/9. 7/9 would be greater than 4/9. So in other words, 4/9 would be less than 7/9. And I can see that since both of my fractions are ninths, they both have a denominator of 9, I'm really just comparing the numerators. And 4 is less than 7. That's a good way to go when you're thinking about comparing fractions. If I'm going to compare 5/6 to 7/10, 5/6 and 7/10 are harder to compare because they don't have a common denominator. But I can easily rewrite fractions to make them have a common denominator. I just have to think of the common multiple of 6 and 10. Where do 6 and 10 meet if I multiply to greater numbers? 6 can become 12, 18, 24, 30. 6 becomes 30. You might have thought 60. Yep, 60 is a common denominator for 5, 6, and 7/10. But 30 is the least common multiple of 6 and 10. 6 can become 30 if I multiply it times 5. Whatever I do to the denominator, I have to do to the numerator. So if I multiply 6 times 5, I have to multiply 5 times 5. So 5/6 is 25/30. To turn 10 into 30, I multiplied it by 3. So to turn the denominator into 30, I'd also have to do the same to the numerator, multiply it by 3 to get 21. So now, as you can see, I have common denominators. So now I'm only going to think about comparing my numerators. Which is greater, 25 or 21? Well, 25 is greater than 21, so 5/6 is greater than 7/10. Take a look at one more example. -3/5 and -5/9. They're both negative. So I'm looking for the one that's a smaller negative or the one that's closer to 0. But it's hard to compare a fraction with the denominator of 5 to a fraction with a denominator of 9. So I'm going to look for a common multiple of 5 and 9. Where do 5 and 9 meet? Well, it happens to be 5 times 9, or 45. They can both become 45. Nine times 5 is 45, so I have to do the same thing to the top. So I'm looking at -5 times 5, or -25/45. On the other side, 5 times 9 gave me 45, so I have to do the same thing to the top. -3 times 9 is -27. So now I'm comparing two numbers with the same denominator. I'm looking at the numerators. Which one is greater, -27 or -25? Well, the one closer to 0 is greater. The one further to the left of 0 is smaller. So -27 is less than -25. So -3/5 is less than -5/9. So being able to find a common denominator and rewrite fractions, rewrite equal fractions with a common denominator so you can compare the numerators is an important skill. Let's take a look at the last part of this target. It's not only comparing fractions, it's also comparing decimals. I like to think about decimals in terms of money. I think money is a really easy way to think about this pretty often. If I'm looking at 0.84 and 0.81, if I think about money, how much money is 0.84? It's 84 cents. to 84 hundredths of a dollar and 81 cents on the other side. It's easy to compare these two numbers if I think about money, because 0.84 is greater than 0.81. Another situation that might come up is with repeating decimals. In this case, 0.34 with a repeating 4 and 0.342, it's a terminating decimal, so it just ends at the 2, might be tricky. I would want to think about what does 0.34 with a repeating 4 look like. I at least would want to think about extending it one more place, because 0.342 also goes one more place. A really good strategy for comparing decimals is to line them up like this, and they both have 0 in the ones place, a 3 in the tenths place, a 4 in the hundredths place. So now we're looking at the thousands place. Which one is greater? The 3, 4, repeating 4 is greater. So 0.34 repeating is greater than 0.342. I could have done that with 0.84 and 0.81. If I line them up and cancel, I'm looking for the place value that helps me determine which one's greater. They both have 8 in the tenths place. The 4 is bigger than the 1, so that's what gave me 0.84 being greater.